According to the National Electrical Code, conduit under a slab is considered inside the building. The National Electrical Code defines a building as any structure having a roof supported by columns or walls. Since the warehouse has a roof supported by walls, the conduit under the slab is considered inside the building. The National Electrical Code does not require a disconnect outside for a 200 amp underground service. However, installing a disconnect outside is good practice for safety reasons. In the event of a fault, the disconnect can be used to disconnect the power to the building from outside. The National Electrical Code Section 230.70 A1 states that the service disconnecting means shall be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. The readily accessible location means it must be able to be reached quickly for operation, renewal, or inspections without requiring those for whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. While not always required for a 200 amp underground service, an exterior disconnect provides a convenient and safe way to de-energize the entire building. This is particularly useful for emergency responders. Several factors influence whether an outside disconnect is installed, including local amendments to the National Electrical Code, utility company requirements, and specific building needs. Local jurisdictions can adopt more stringent requirements than the National Electrical Code. The utility company supplying power may also have specific requirements for disconnect locations. The type of building and its occupancy can also influence the decision. For example, a building housing critical infrastructure might benefit more from an external disconnect. The National Electrical Code defines service conductors as the conductors from the service point to the service disconnecting means. The service point is defined as the point of connection between the facilities of the serving utility and the premises wiring. The service disconnecting means is a device or group of devices used to disconnect all conductors in a building or other structure from the service entrance conductors. The National Electrical Code Section 230.70 covers the general requirements for service disconnecting means. This section requires that the service disconnecting means be readily accessible and suitable for the prevailing conditions. The National Electrical Code also requires that the service disconnecting means be legibly field marked to indicate its purpose unless located and arranged so the purpose is evident. The location and accessibility of the service disconnecting means are critical for safety and ease of maintenance. Firstly, it should be readily accessible to authorized personnel. Secondly, it should be protected from physical damage. Thirdly, it should be clearly labeled. There are several types of service disconnecting means available, including circuit breakers, fuse switches, and combination units. A circuit breaker is a device designed to open and close a circuit by non-automatic means and to open the circuit automatically on a predetermined overcurrent without damage to itself when properly applied within its rating. A fused switch is a switch in combination with fuses. A combination unit includes both a circuit breaker and a fuse switch. The choice of service disconnecting means depends on several factors, including the size of the service, the available space, and the desired level of protection. When installing an underground service, the conduit must be properly sized and installed to protect the conductors from physical damage and moisture. The National Electrical Code Article 300 provides general requirements for wiring methods. The National Electrical Code Section 300.5 covers the requirements for underground installations. The National Electrical Code Section 300.5 D specifies the minimum cover requirements for underground wiring. The depth depends on the voltage, the type of wiring method, and the location. For example, direct buried cables typically require a greater burial depth than conduit encased conductors. The type of conduit used for underground installations depends on the application. Rigid metal conduit, intermediate metal conduit, and rigid polyvinyl chloride conduit are commonly used. Each type has its own advantages and disadvantages in terms of cost, durability, and ease of installation. Proper grounding and bonding are essential for electrical safety. The National Electrical Code Article 250 covers the requirements for grounding and bonding. Grounding refers to connecting the electrical system to the earth to provide a low-impedance path for fault current. Bonding refers to connecting metallic parts of the electrical system together to create an electrically conductive path. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete-encased electrode. The grounding electrode conductor connects the grounding electrode system to the equipment grounding bus in the service panel. Equipment grounding conductors are used to connect metallic enclosures in equipment to the grounding system. This helps to ensure that fault currents will flow back to the source, causing the overcurrent protective device to trip and energize the circuit. The National Electrical Code Section 250.24 specifies that the grounded conductor shall be connected to a grounding electrode conductor at the service. This connection provides a path for fault current to return to the source. The National Electrical Code Section 250.32 covers the grounding requirements for separate buildings or structures. If a building or structure is supplied by a feeder or branch circuit, a grounding electrode system must be installed at the separate building or structure. Surge protection devices can help protect sensitive electronic equipment from voltage surges caused by lightning or other disturbances. The National Electrical Code Section 230.8 covers the requirements for surge protection devices. The National Electrical Code requires that surge protection devices be installed in certain locations, such as dwelling units and critical facilities. The installation of a 200 amp underground service requires careful planning and attention to detail. It's essential to comply with all applicable codes and standards to ensure a safe and reliable electrical system. The location of the service entrance, the type of wiring method, the grounding and bonding system, and the service disconnecting means are all critical considerations. Firstly, consult with the local building department and utility company to determine the specific requirements for your area. Secondly, use qualified and licensed electricians to perform the installation. Thirdly, ensure that all work is inspected and approved by the local authorities. The National Electrical Code Article 230 provides comprehensive requirements for service entrances. This article covers various aspects of service entrances, including clearances, protection against physical damage, and overcurrent protection. The National Electrical Code Section 230.9 covers the clearance requirements for service conductors. The clearance requirements depend on the voltage, the location, and the type of conductor. For example, service conductors over residential property typically require a greater clearance than service conductors over commercial property. The National Electrical Code Section 230.22 covers the insulation requirements for service conductors. Service conductors must be insulated to prevent electrical shock and leakage current. The type of insulation depends on the voltage and the environmental conditions. The National Electrical Code Section 230.42 covers the ampacity requirements for service conductors. The ampacity of the service conductors must be sufficient to carry the load served. The load calculation must be performed in accordance with the National Electrical Code Article 220. The National Electrical Code Section 230.50 covers the protection of service conductors against physical damage. Service conductors must be protected from physical damage by conduit, raceway, or other approved means. The type of protection depends on the location and the potential for damage. The National Electrical Code Section 230.71 covers the maximum number of service disconnecting means. The National Electrical Code generally limits the number of service disconnecting means to 6. This requirement is intended to simplify the disconnection of power in an emergency. The National Electrical Code Section 230.82 covers the equipment permitted on the supply side of the service disconnecting means. Certain types of equipment, such as surge protection devices and metering equipment, are permitted on the supply side of the service disconnecting means. It is essential to coordinate the installation of the service entrance with the utility company. The utility company will typically provide the service drop or service lateral and will also specify the location of the meter. It is also essential to obtain all necessary permits and inspections before commencing work. Failure to obtain the necessary permits and inspections can result in fines and delays. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is essential to stay up to date with the latest edition of the National Electrical Code to ensure that your electrical installations are safe and compliant. Several resources are available to help you understand and comply with the National Electrical Code. The National Fire Protection Association publishes the National Electrical Code. Many training programs and seminars are available to teach you about the National Electrical Code. Numerous websites and online forums provide information and assistance with the National Electrical Code. When designing and installing a 200 amp underground service, it is important to consider the long-term maintenance and reliability of the system. Choose high-quality materials and components that are designed to withstand the harsh underground environment. Provide adequate access for inspection and maintenance. Regularly inspect the service entrance for signs of damage or deterioration. The National Electrical Code Section 110.12 covers the mechanical execution of work. This section requires that electrical work be installed in a neat and workmanlike manner. The National Electrical Code Section 110.14 covers the electrical connections. Electrical connections must be made in a manner that ensures a reliable electrical connection. The National Electrical Code Section 110.16 covers the arc flash hazard warning. An arc flash hazard warning label must be placed on electrical equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. The arc flash hazard warning label provides information about the potential arc flash hazard and the personal protective equipment required to protect against the hazard. The National Electrical Code Section 110.21 covers the marking requirements for electrical equipment. Electrical equipment must be marked with the manufacturer's name, trademark, or other descriptive marking by which the organization responsible for the product can be identified, and the voltage, amperage, wattage, or other ratings as are prescribed elsewhere in this code. Understanding the National Electrical Code requirements for underground services and disconnects is crucial for ensuring a safe and compliant electrical installation. While an external disconnect is not always mandated for a 200 amp underground service, it is generally considered a best practice for enhancing safety and facilitating emergency shutdowns. Always consult the latest edition of the National Electrical Code and local amendments to ensure compliance.